video, I will discuss about the specific tools and methods for moving data into Hadoop, including tools for basic file transfer, batch transfer, and stream data processing. File transfer is the simplest and sometimes fastest way to get data into and out of Hadoop, using the Hadoop fs put and the Hadoop fs get commands. File transfer is often considered as the first option and best for ingesting the existing files and keeping them in their source format. File transfer is not a good option for ingesting data into multiple locations. Sqoop is a good option for batch transfer between Hadoop and relational databases. When used for importing data into Hadoop, Sqoop generates map-only MapReduce jobs, where each mapper connects to the database using a Java database connectivity driver. Using a Sqoop, users can select a portion of the table to be imported and write the data to HDFS by adding where clauses to filter the data and supplying custom queries. Sqoop uses multiple mappers to parallelize the data ingest and increase throughput. There is a very common use case of having to ingest many tables from the same RDBMS using two approaches. First option is to load the tables sequentially, which is the simplest way, with the drawback of not optimizing the bandwidth between the RDBMS and the Hadoop cluster. Second option is to load the tables in parallel, which use resources more effectively, but it adds the complexity of managing the total number of mappers being run against the RDBMS at the same time. Flume is a distributed, reliable, and available system for the efficient collection, aggregation, and movement of streaming data. Flume architecture consists of multiple components. Flume sources ingest events from external sources and forward them to channels. External sources could be any system that generates events such as social media feeds like Twitter or machine logs. Flume interceptors allow events to be intercepted and modified in flight. This can be transforming the event, enriching the event, or basically anything that can be implemented in a Java class. Some common uses of interceptors are formatting, partitioning, filtering, or splitting. Selectors provide routing for events. Selectors can be used to send events down zero or more paths, so they are useful if you need to fork to multiple channels or send to a specific channel based on the event. Flume channels store events until they are consumed by a sink. Sinks remove events from a channel and deliver to a destination. The destination could be the final target system for events, or it could feed into further Flume processing.